I'm going to start by drawing a part of a curve. There we go, there's a part of a curve. And we've recently been looking at this idea whereby if you've got a straight line that just touches that curve at a particular point, so that line is supposed to just touch there and nowhere else, then this line is called the tangent. The tangent to the curve at that particular point. And we've recently worked out how you can find the equations of those tangents using differentiation. Now another line you may well be expected to find the equation of is the one which passes through the same point but which is perpendicular to the tangent. We call this line the normal. This is called the normal to the curve at that point, because rather than just touching there, it's perpendicular to the line that just touches. It cuts straight through it perpendicularly. There are other contexts where you may have heard the word normal. I mean, if you think of it, if any of you have done scientific experiments with a glass block where a beam of light comes in from a ray box, then when it goes into the box it changes direction. In fact, what you do to work it out more technically is you draw an imaginary line perpendicular to the block at the point where they intersect, and you find that the angle on the outside is bigger than the angle on the inside, and you say that the light bends towards the normal, so this line is called the normal. There's just another context where we use the word normal to mean something that's at right angles too. So in this case, in the case of a curve, we might be expected to find the equation of the normal rather than the equation of the tangent to the curve at a point. Well, there's one thing that can help us very easily here. The nice thing is, if you have any two lines which are perpendicular to each other, and if one of them has got a gradient of m1 and the other one has got a gradient of m2, then it turns out that if you multiply those two gradients together, you get -1. That is not phenomenally difficult to prove, but we're just going to use that as a fact here so we can get on and find the equations of normals. So if my first line, for example, was y equals 3x plus 4, and I wanted to know the gradient of this line, well, that means that my m1, my gradient to my first line, is 3. That means that 3 times m2 is -1, or dividing through by the 3, the gradient of the perpendicular line is -1 over 3. And in fact, in general, it's easier to probably use this equation in that form. You can say that I can get the second gradient, I can get the perpendicular by doing -1 over the first gradient. So that means that if we want to find the equation of a normal, what we always need to find the equation of a straight line is a gradient and a point. Well, if we know the gradient of the tangent, which we get by differentiating, we can get the gradient of the normal by doing this trick, by doing the m2 equals -1 over m1. Well, let's do an example to that. Suppose we had the curve y is 3x cubed subtract 2x, and I want to find the normal to that curve at the point where x is 2. So let's start off by finding the gradient of the tangent to the curve, which you get by differentiating. Differentiate, we'll get 9x squared subtract 2. At the particular point with an x coordinate of 2, that means that the gradient of the tangent will be 9 times 2 squared, which is 4. 9 times 4 is 36. Subtract 2 is 34. That means that the gradient of the normal, rather than the gradient of the tangent, will be -1 over 34. So now we know the gradient of the normal. We're getting closer to be able to actually work out the equation of the normal. Now we won't just need the x-coordinate, of course we're going to need the coordinates of the point. We're going to need to know what y is when x is 2. So when x is 2, that means that y is 3 lots of 2 cubed. 2 cubed is 8. 3 lots of 8 is 24. Subtract 2 lots of 2, subtract 4. The y coordinate is 20. So we're in a position now where we know that we have got a point with coordinates 2, 20. And we've got a gradient, which in this case, because it's a gradient of the normal we want to use, is negative 1 over 34. We can go straight to saying y subtract y1 is equal to m into x subtract x1. In other words, y subtract 20 is equal to negative 1 over 34 into x subtract 2. Well, the numbers are not coming out very nicely in this case. Once again, that's because I just made it up as I went along. You will usually be presented with questions where the numbers come out a bit more smartly than this. Subtract, no, negative, negative, so it's plus 2 over 34, that's 1 over 17. So y is negative 1 over 34 x's plus a 17th plus 20. And I can't, to be honest, be particularly bothered with adding that 17th to that 20th to get a single number, but we have a straight line, which is y equals some x's plus some number. We have the equation of a straight line. So, in summary, if you want to work out the equation to the normal to a curve at a point, firstly, find dy dx at that point. Let's suppose that we've called that m1. 2. Work out not the gradient of the tangent m1 that you've got, but your new gradient, which is negative 1 over the gradient of the tangent. This is the gradient of the normal. And then finally use y subtract y1 is equal to m2 in this case, the gradient of the normal, x subtract x1, where x1, y1 is the point we're interested in. If you haven't got the y coordinate of the point, if you've only got the x coordinate, you'll have to work that out.